Yesterday's state-of-the-art technology is today's retro device. From the image itself, you can see that with the more developing time and also technology, we need more sophisticated, more advanced devices which outsmarts ST device. But to produce this kind of devices, we need one of the most important thing, that is material, because whatever technology is there, it's totally limited by the material we use. So but the materials are limited, then how we can change the material to match the growth of this rapidly evolving technology. To create new materials, it's very cumbersome and time taking because the permutation and combinations itself are very huge. So to do that, what we need to do, because we cannot trial add every new alloy and get a new material, it's impossible. So what's the best and effective way to meet the rapidly changing technology is to change the design approach itself. If you see, the design approach which we follow is totally based on, first is our energy choice, like how much energy does it make to get thing, that was we use. But if you go to the nature, like more biomimicry, it first takes the information and also the structure, which tries to get into both and tries to get the best structure possible. That is, it tries to understand the system, what are the forces acting on it, what kind of environment it's there, and try to develop the structure which can automatically give the best result possible with as less material as possible. That is the way of nature. So with the aim of this nature design approach, we can develop new technologies and also new materials which will be the best of the best. So one of the major examples you can see from this here, the aircrafting. If you see aircrafting, it has got lots of important consideration. Like one of the major consideration is that my overall global target, the weight should be very less. But if you see inside, we want a strong structure at the front so that it can withstand high force from the air, and backside no need that much strong comparing the front side, and inside it should be hollow. Then what should I do? And you know, the one material itself cannot be made to classify, to not only classify but also to get all the required properties from just one material structure. So based on from nature, where in nature also this hierarchy there, so getting the inspiration from it, you can consider a hierarchy device where each level of hierarchy gives its own unique property, so that globally you will able to achieve the required properties at different levels. So that is the major advantage by following the nature's method. So one of the best way to implement this is using by triple periodic minimal surface. These are one of the meta materials, you can say, which we can control like as per our needs. We can control the topology to meet our requirements, and this structures has got very huge potential. So this work majorly uses this TPMS to get the required properties of what you needed. And from this slide also you can see how we can change the topology of the TPMS so that you can code the required strength into TPMS as per your needs. Now the question is that you have the TPMS, but the thing is, like, mostly the final shape of the structure is mostly fixed. You are not able to change it, but you want to implement TPMS into this. But you can see from the previous slides, this TPMS are very complex topologies. So how to use it? So for that reason, the scaffold generator comes in the picture. What you can do is, like, you can simply take your STL file of your required shape, like whether it be a very complex shape, even you can see from there the Stanford one of the complex shape, you can take it, input in the software and change input, like whatever infill you want to give, like you can give gyroid, primitive, like whatever shapes you want. There are like 11 total shapes in the software. From that you can input, control the topology itself. It gives all the three topologies which we discussed in previous slide: variable density, hierarchy, and also hybridization. So from that you can simply change, get the parameters, and you can convert. It's very simple. So this is the UI of the scaffold generator. It is very easy to use, and it's designed in such a way, the UI was designed in such a way so that even a simple person can be able to use. So you can simply, if you have the STL file of your object, you can simply take it, give the required TPMS to infill it by depending on what you want, and you can get the required structure. So now you can see the UI of the scaffold generator. So first what we need to do is the input our STL file. Even before that you can see all the required function like variable density, cell size grading, hybridization. So what does it do is like whatever structure which you input, it's going to take and fill the structure with your required TPMS. So for that you can take load STL. Once you click the load STL, now you get the option to take any STL file. So once we input the STL file, it's gonna show what kind of STL file you inputted also. Now I think it should be coming, and till the time you can also like change your required parameters, like how much I need to, like which kind you want to do. So you can fill. Now I think you can see the torus shape. So the STL file just shows in it. So it shows like now your structure is loaded. Once it is loaded, what you can do is input your required, like give your all the required things like guide rod, SP. For let us take guide rod itself. Then you can click the plot. So once you click the plot, it's gonna run. It's gonna fill whole structure with the required TPMS. And even this level set function you can use to change your required density. Now you can see it is totally filled. You can see now. So the torus shape is totally filled with your required TPMS. So once this is done, you can close this and you can export. So you will be exporting in same as like STL file itself. So that once you convert into STL file, now you can even get that it's 3D printed. So you can store it as like TPMS torus. So it gets saved, and from that you can simply use your required structure.